These are your notes for Unit 6, Day 2 of Pre-Calculus. If you would like to see your warm-up, the review question, or any homework questions we covered in class today, just look at your finished notes. So today we're going to talk about SOHCAHTOA. So we'll talk about finding the exact value of the trigonometric functions given a point on a circle. So we're going to do triangles in our circles. So sine, cosine, tangent, cosecant, secant, and cotangent. We're going to be able to use special right triangles to find the degree or to find those measurements of different angles within a unit circle or a circle on the coordinate plane. And then we'll also be able to use our calculator to approximate the values of those trig functions. So the 6 trig functions. So let's just call this angle down here theta. And then if you remember, you have SOHCAHTOA. So we labeled the sides first. The hypotenuse is always across from the 90-degree angle. So this side is going to be the hypotenuse. The side opposite theta is called the opposite side. And the side next to theta that's not the hypotenuse, we call the adjacent side. And then you have your trig ratios. So the sine of an angle is so it's the opposite side divided by the hypotenuse. So if you take opposite divided by hypotenuse, you get sine. The cosine of an angle is cos, so it's adjacent over hypotenuse. So if you take the adjacent side divided by the hypotenuse, you get the cosine of an angle. And then the tangent of an angle is TOA, so it's the opposite side divided by the adjacent side. And those are the 3 trig ratios. And then the other 3 are their reciprocals. So the cosecant of an angle is the reciprocal of sine, so it's 1 over sine. So it's the hypotenuse divided by the opposite side. So cosecant is the reciprocal of sine. Secant is the reciprocal of cosine, so it's 1 over the cosine. So it'll be the hypotenuse divided by the adjacent side. And then cotangent is the reciprocal of tangent, so it's 1 over tangent. So it is the adjacent side divided by the opposite side. And those are your 6 trig ratios. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So for instance, let's just call this theta, and let's say we have a 3, 4, 5 right triangle. So the sine of that angle would be opposite over hypotenuse, so it would be 3/5. The cosine of that angle would be adjacent over hypotenuse, so it would be 4/5. The tangent of that angle would be opposite over adjacent, so 3/4. And then the cosecant would be the reciprocal of sine, so 5/3. Secant would be the reciprocal of cosine, so 5/4. And cotangent would be the reciprocal of tangent, so 4/3. So the unit circle and the trig functions. So for instance, if we were going to let's do 30 degrees. So if we were to go out 30 degrees, and so that would be our angle. The angle that we want is always going to be right there at the origin. So that's the angle that we want. So if we wanted 30 degrees and we wanted to find the sine, cosine, and tangent of 30 degrees. Well, if it's a unit circle, the radius is going to equal 1. So in a unit circle, the radius is 1. So this right here, the hypotenuse is going to be the radius, because notice it goes from the center to the outside. So the radius is 1. And then if you remember in a 30, 60, 90 degree triangle, how it works, if the hypotenuse is 1, across from the 30 is half that, and then across from the 60, which would be the other angle, would be the shorter side times square root 3, so it would be square root 3 over 2. So across from the 30 is 1/2, and then across from the 60 would be square root 3 over 2. And so that is just a triangle that you should know and have in your long-term memory. So it's 1, 1/2, and square root 3 over 2. So now if we wanted to find the sine, cosine, and tangent of 30, well, the sine of 30 degrees is going to be opposite over adjacent, so it'd be 1/2 over 1, so it's just 1/2, because opposite over adjacent. And then, opposite over hypotenuse. And then if we wanted to find the cosine of 30, it would be adjacent over hypotenuse. So it'd be square root 3 over 2 over 1. So it's just square root 3 over 2. And then if we wanted to find the tangent of 30 degrees, it would be opposite over adjacent. So it'd be 1/2 over square root 2, or yeah, 1/2 over square root 3 over 2, which is 1 over square root 3. And if you rationalize, you get square root 3 over 3. And so that is the sine, cosine, and tangent of 30 degrees. If you wanted to find their reciprocals, the cosecant of 30 degrees, you would flip over sine and you would get 2. The secant of 30 degrees, you would flip over cosine and you'd get 2 over square root 3. And if you rationalize that, you get 2 square root 3 over 3. And then the cotangent of 30 degrees, you would flip over 1 over square root 3 and you'd get square root 3. And those are the 6 trig ratios for 30 degrees. And remember, 30 degrees in radian is the same thing as pi over 6. So the sine at pi over 6 is 1/2. The cosine at pi over 6 is square root 3 over 2, etc. Okay, so that's for the 30, 60, 90 if we're doing the 30-degree angle. Let's do the same thing, but with the 60-degree angle. So let's do that. So let's do a 60-degree angle. And so we know that the radius is 1. We know that the shorter side's 1/2. And then across from the 60 will be square root 3 over 2. So now if I wanted to do my sine, cosine, and tangent for 60, the sine of 60, and remember 60 degrees in radians is going to be pi over 3. So it's the same thing if I was doing the sine of pi over 3 or the cosine of pi over 3. So the sine of 60 degrees is going to be opposite over hypotenuse, so it'll be square root 3 over 2. The cosine of 60 degrees is adjacent over hypotenuse, so it'd be 1/2. The tangent of 60 degrees is going to be square root 3 over 1, which is just square root 3. And then if we flip all of those over, the cosecant of 60 degrees is going to be 2 square root 3 over 3. The secant of 60 degrees is going to be 2. And the cotangent of 60 degrees is going to be square root 3 over 3. And those are the 6 trig ratios for 60 degrees, or pi over 6. And then our last special right triangle is the 45, 45, 90-degree triangle. So if we have a 45-degree angle, we know that the hypotenuse is still 1. And then remember, in a 45-degree right triangle, we have 1, and then it would be square root over 2 and square root over 2 for the other two sides. And you just get those using the Pythagorean theorem. So those two sides would be square root 2 over 2 and square root 2 over 2. So the sine of 45 degrees is going to be opposite over hypotenuse. So it'll be square root 2 over 2. The cosine of 45 degrees is going to be square root 2 over 2. The tangent of 45 degrees is going to be 1. And then if you flip all of those over, the cosecant of 45 degrees is square root 2. The secant of 45 degrees is square root 2, and the cotangent of 45 degrees is 1. And so that's what you would get for the 6 trig ratios for 45 degrees. And remember, 45 degrees is the same thing as pi over 4 in radians. And this is for 60 degrees, which is the same thing as pi over 3 in radians. So that's how you can use the unit circle to come up with the sine, cosine, and tangent for 30, 45, and 60 degrees. All right, so let's let P be equal to negative 1/2 square root 3 over 2, be a point on the unit circle that corresponds to T. Find the values of sine T, cosine T, tangent T, cosecant T, secant T, and cotangent T. All right, so we are at negative 1/2 for x. So we're right here, and then square root 3 over 2. So we'll be right here. So to do it, if they're not giving you a degree measurement and they're just giving you a point on the circle, first you draw that point on the circle, and then we've got to draw a right triangle. So you start at the origin, draw a point, draw to the point on your circle. So this is negative 1/2, and then square root 3 over 2. And then to finish your triangle, you always connect it back to the x-axis. So there's my right triangle. Since it's a unit circle, we know that the radius is 1. And then we need to know the length and height of that triangle. How far out did we go? Well, we went out the x value. So this is going to be -1/2. And how far up did we go? Well, we went out up the y value. So that's going to be square root 3/2. And so now if we want to find the sine, cosine, and tangent, well, the angle is always going to be down at the origin. So it's going to be down there. And now we're just going to use that triangle. So the sine is going to be the opposite over the hypotenuse. So it's going to be square root 3/2. The cosine is going to be adjacent over hypotenuse, so it's going to be -1/2 over 1, so it's going to be -1/2. The tangent of that angle is going to be the opposite over the adjacent, so square root 3/2 over -1/2, so that's going to be negative square root 3. And then flip all of those over. So the cosecant of that angle is going to be 2 over root 3, which is 2 root 3/3. The secant of that angle, flip over cosine, you get -2. And the cotangent of that angle, flip over negative square root 3, and you get -1 over root 3, so negative root 3/3. Now, something to keep in mind when we're doing this. When you make your triangle, so if I were to make my triangle here, notice that my x values are positive and my y values are positive. So all of my angles are going to be positive in that first quadrant, all of my sine, cosines, and tangents. If I make it in the second quadrant, my x's are negative and my y's are positive. So if you think about it like that, in your angle, if we were to do these, remember it's opposite, sine is the opposite side over the hypotenuse. Well, the hypotenuse is always going to be positive because it's the radius of your circle, so that's always going to be positive. The opposite side in your triangles depends on the y-coordinate. So sine of your angle is going to depend on the y-coordinate. So whether the y is positive or negative is going to determine whether sine is positive or negative. If you wanted to find the cosine of your angle, well, cosine is adjacent over hypotenuse, and the adjacent side is the x-coordinate. So if you want to figure out whether the cosine is going to be positive or negative, you need to look at the x-coordinate of where you're at. If the x-coordinate is positive, then your cosine is going to be positive. If the x-coordinate is negative, then your cosine is going to be negative. And then for tangent, tangent is the opposite side over the adjacent side. So tangent depends on both the y over the x. So when you're doing these, the anagram or the mnemonic device that I use, if you're in the first quadrant, second quadrant, third quadrant, or fourth quadrant, it's all students take calculus. So in the first quadrant, everybody's positive because y and x are positive. So sine, cosine, tangent are all positive. In the second quadrant, you have students, so only sine is positive in the second quadrant. So sine and its reciprocal are positive in the second quadrant because the y values are positive and sine depends on the y values. The x's are negative in that quadrant. In the third quadrant, you've got take, so only tangent and its reciprocal are positive in that third quadrant. So tangent and cotangent are positive in the third quadrant. And then that last one is calculus. So cosine is the one that's positive in the fourth quadrant. So cosine of your angles will be positive in the fourth quadrant because your x values are positive in the fourth quadrant and the y values are negative. All right. So the exact values of the trig functions of the quadrantal angles. So 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then 360 degrees. So we've already done our special right triangles, which we'll review again in a second. But if we wanted to do this, if you are thinking about this again, remember the sine of our angle depends on the y-coordinate. So whatever the y-coordinate is going to give you the sine of your angle, or it's going to tell you whether it's positive or negative. The cosine of an angle is going to be determined by the x-coordinate, the sine of it, so whether it's positive or negative. And then the tangent of your angle is determined by the y-coordinate over the x-coordinate. So if we are at 0 degrees, we are at the point 1, 0. So if we wanted to do 0 degrees or 0 pi or 2 pi or 360 degrees, the sine is going to be the y-coordinate. Well, the y-coordinate there is 0. So the sine of, not theta, the sine of 0 is 0. The cosine of 0 is the x-coordinate, not theta. So the cosine of 0 degrees, or 0 pi, is going to be 1. The tangent of 0 is the y over the x, so it's 0 over 1, which is 0. And so if you are at 0 or 360, the sine is 0 because that's the y-coordinate. The cosine is 1 because that's the x-coordinate. And the tangent is 0 because that's y over x. All right, if you're up at 90 degrees, or pi over 2, then the sine at pi over 2, or the sine at 90, is going to be the y-coordinate. The y-coordinate is 1 up there. The cosine of 90, or the cosine of pi over 2, is going to be 0 because that's the x-coordinate. And then the tangent of 90 is going to be 1 over 0, which is undefined. So the tangent of 90 is undefined. All right, let's go out to 180. So if I'm out to 180 degrees, and 180 degrees is just pi, the sine at 180 degrees, or at pi, is the y-coordinate, which is 0. The cosine at 180 degrees is the x-coordinate, which is -1. And the tangent of 180 degrees is the y-coordinate over the x-coordinate, which is 0. So those are your trig ratios at 180. And then let's go down to 270. So if I'm down at 270, so 270 degrees is the same as 3 pi over 2 in radians. So the sine at 270 is the y-coordinate, which is -1. The cosine at 270 is the x-coordinate, which is 0. And the tangent at 270 is the y over the x, which is undefined. And those are your trig ratios at the quadrantal angles. All right, we already talked about our special right triangles. So if we are at the 30, 60, 90, remember that this is 1/2 square root 3 over 2 and 1 for the unit circle. And then for the 45, 45, 90 degree angle, we've got square root 2 over 2, square root 2 over 2, and 1. And then we already listed all of the special angles up above, so see above, for the sine, cosine, tangent, and the reciprocals of those three. So these are the tables that you should know, learn to love and memorize. So if you are at 0 degrees or 0 radians, the sine of 0 is 0, the cosine of 0 is 1, the tangent of 0 is 0, and then those are the reciprocal values. And then, so these are all the quadrantal angles. And then the pi over 6, which is 30 degrees, pi over 4, which is 45 degrees, and pi over 3, which is 60 degrees. Those are also listed in this table, and we also listed them up above. So you should work on memorizing these tables or knowing how to come up with them quickly using the triangles and the unit circle. I would probably just memorize them. So I would work on memorizing those tables the next couple of nights. All right. So let's find the exact value of each of these expressions from those tables. So the sine of 45 degrees, you can look that up at the table up above. It's the square root of 2 over 2. And then the cosine of 180, if you look that up above, it's -1. So you have the square root of 2 over 2 times -1. So that'd be -√2 over 2. And then again, the tangent at pi over 4, well, pi over 4 is the same thing as 45 degrees. So the tangent at 45 degrees is 1. And then minus the sine at 3 pi over 2. Well, 3 pi over 2 is 270. And the sine at 3 pi over 2 is -1. So it's 1 minus -1, which is 2. The secant at pi over 4. So that's the secant at 45 degrees, which is √2. So we have √2 squared plus the cosecant at pi over 2. That would be 1 over the sine at pi over 2, which is 1. So you have √2 squared, which is 2, and then 2 plus 1, which is 3. So again, these types of problems are going to go a lot faster once you have those reference tables up above memorized. All right, so we've talked about 30, 60, 90, 45, and then 90, 180, 270, 360. Well, what if we're not at one of those? Let's say that we are at 225, and we want to know what the sine, cosine, and tangent of 225 is. Well, first, we've got to go 225 degrees. So here's 180. And then we've got to go to 225. So we've got to go 45 degrees more. So that 45 degrees more is what we would call the reference angle. So here's 180, and we've got to make it down to 225. So our reference angle is 45 degrees. So that's the triangle that I'm making because that's going to be my reference angle. So the reference angle is going to be 45 degrees for that. And so if I did my 45, I would have square root 2 over 2. This one would be negative square root 2 over 2, and this is 1. So if we wanted to find like the sine of 225, it would be opposite over hypotenuse, so it would be negative root 2 over 2. If I wanted to find the cosine of 225, it'd be adjacent over hypotenuse, which would be square root 2 over 2. Oh, these are both negative, sorry. Because I'm on the negative side of the x-axis and I'm on the negative side of the y-axis. If I wanted to find the tangent of 225, I would have negative over a negative, and they're the same, so it'd be positive 1. So that's how you can do it if you are in degrees. And then remember, it's all students take calculus. So everybody's positive in the first quadrant. Only sine is positive in the second quadrant. Tangent is positive in the third quadrant. And cosine is positive in the fourth quadrant. So if you're in degrees, that's how you can do it. It's almost nicer if you are in radians, because when you're in radians, that's automatically giving you the reference angle. So if I had 5 pi over 6 and it wanted to know, okay, what are the sine, cosine, and tangent of 5 pi over 6? Well, this little piece right here is giving you the reference angle. So without that coefficient in front, you are getting the reference angle. So what is pi over 6? Pi over 6 is 30 degrees, so I have a 30-degree reference angle. So I know that I'm going to use 30 degrees as my reference angle, so I'm going to use the 30, 60, 90-degree triangle to come up with my values. That 5 in front, I take that times the 30, and that's going to tell me where I'm located. So I'm at 150 degrees, so I'm right here. So this is my 150 degrees. So my triangle would be right here, and I have a 30-degree reference angle. To get from 150 back to 180, I need to go 30 degrees. And so we have negative 1/2. Sorry, that's not where the 1/2 goes. We have positive 1/2. We have negative square root 3 over 2, and we have 1. So if we wanted to find the sine of 5 pi over 6, sine is opposite over hypotenuse, which would be 1/2. The cosine at 5 pi over 6 is adjacent over hypotenuse, which would be negative square root 3 over 2. The tangent at 5 pi over 6 would be opposite over adjacent, which would be negative square root 3 over 3. All right, so let's say we wanted to find let's say we wanted to do negative 3 pi over 4. So negative 3 pi over 4, our reference angle, we look at pi over 4, so we look at the little fraction without the coefficient front first, and that's 45. And then if we do negative 3 times 45, we would get negative 135. So we're going to be at negative 135. And remember, if you have a negative angle, you're rotating down. So I'm right here. So that's going to be negative 135. And then we know that the reference angle is going to be 45 degrees. To get to the nearest x-axis, we have to go 45 degrees. And so I know that I want the 45 degrees from my table, and I'm in the I'm in the third quadrant, and in the third quadrant, all students take only tangent is going to be positive. So I'm going to do my table at 45. So if I know the sine at 45, so the sine at negative 3 pi over 4, the sine at 45 degrees is going to be negative root 2 over 2. And since only tangent's positive, it's going to be negative root 2 over 2. The cosine at negative 3 pi over 4 is also going to be negative root 2 over 2. And then the tangent of negative 3 pi over 4, well, the tangent at pi over 4 is 1, and I'm in the third quadrant where tangent's positive, so it'll also be 1. All right, so go ahead and see if you can pause the video and try A, B, C, D, and E. So see if you guys can find those values based on the reference angle and what quadrant you're in, whether it'll be positive or negative. All right, so the cosine at 5 pi over 4 is 45 degrees. And if we wanted the 5 times pi over 4, we would be down here. So we would be at 225 degrees. And so it's all students take calculus. So tangent is the only one that's going to be positive, so it's going to be negative. And I know that the cosine at 45 degrees is root 2 over 2, so this is going to be negative root 2 over 2. The sine at 135, so 135, I'd be right here. So all students take calculus. I know sine would be positive there. And I know that if I'm at 135 to get to the closest x-axis, my reference angle is going to be 45. And I know that the sine at 45 is root 2 over 2. So this is going to be positive root 2 over 2. The tangent at 315, well, 315 is going to be down here. And then to get to the closest x-axis, I need to get to 360, so I need 45 more. So my reference angles is going to be 45. All students take calculus, so tangent's going to be negative in that quadrant. And tangent at 45 is 1, so it'll be negative 1. The sine at pi over 4, negative pi over 4, so negative pi over 4 I'd be down here. All students take calculus. Sine is negative in that quadrant, and at pi over 4, sine is square root 2 over 2, so it'll be negative square root 2 over 2. The cosine at 11 pi over 4, well, I know at 8 pi over 4, I'm at 2 pi. So I need to go all the way around, and then I need another 3 pi over 4. Well, 3 pi over 4, I'd be over here. And so my reference angle is 45 degrees, and I'm in the second quadrant, so all students take calculus. Only sine's positive in that quadrant. So the the cosine at pi over 4 is root 2 over 2, and it's negative because cosine's negative in that quadrant. All right, so using our calculator to approximate these. So we're in degrees, so this is where we got to know how to switch between degrees and radians. So if we wanted the cosine of, let's make sure, so up in that little wrench is where you can switch from degrees to radians. So notice down at that bottom it says radians degrees. I'm going to highlight degrees so that I'm in degrees on this. So if I did the cosine of 48, I'd get 0.669. We'll go out 3 decimal places. If you wanted to do the cosecant at 21, well, cosecant is 1 over the sine. So we're going to do 1 over the sine of 21 degrees. So we'll do 1 divided by, and then we'll do the sine of 21 degrees. And you get 2.790. And then if we want to do the tangent at pi over 12, so now we are in radians. So we're going to go tangent, and then we'll hit the little wrench, make sure we're back in radians, and then we're going to do pi divided by 12. And the tangent of pi divided by 12 is going to be 0.269. And there we go. So that's how you can use your calculator to evaluate trig ratios. Oh, it said 2 decimal places. We went out 3. That's okay. All right, find the exact values of each of the 6 trig functions of an angle theta if 4, -3 is a point on the terminal side in standard position. So again, this is like that problem we did earlier. So we're going to start here, and then we're going to go to the point 4, -3. So 1, 2, 3, 4, 1, 2, 3. So 4, -3. So we're going to not put the dot there. So 1, 2, 3, 4, and then -3. So this is going to be where I end. So remember, you connect from the origin to that point, and then you form a right triangle back to the x-axis. So here's my theta in there. And then we know that we went 4 out and we went 3 down. And now we need to find, it's not a unit circle, so we're going to have to find the radius of that circle, or we're going to have to find the hypotenuse using the Pythagorean theorem. So 4 squared plus -3 squared, we'll call that r, so it will be equal r squared. So 16 plus 9 equals r squared. So 25 equals r squared, so r is going to equal 5. That's always going to be positive. So now I have basically a 3, 4, 5 right triangle. And so now if I wanted to find the sine of that angle, well, sine is opposite over hypotenuse, so it would be -3/5. Cosine of that angle would be adjacent over hypotenuse, so it would be 4/5. Tangent of that angle would be opposite over adjacent, so -3/4, and then flip them over. So cosecant of that angle would be 5 over -3. Secant of that angle would be 5 over 4. And cotangent of that angle